Okay, welcome back everybody. This is the as promised fourth and fifth axis positioning video. Sure you all recognize this little Turner's cube from school. We've 3D printed this thing. We've made it just in vices, and now with the new Haas TRT, we've done a fifth axis program. So I'm not going to focus too much on the machining aspect of this. We will put the toolpaths down that are necessary, but mostly want to focus on showing you guys how Mastercam creates the rotation that allows us to get to these faces. So first thing we're going to need is a machine. So I'm going to go in here, I'm going to select the mill, and I'm going to go ahead and select the 5-axis mill. So there's kind of two ways that this is normally done. Essentially, we need a plane for each of the faces that we're going to machine. So depending whether you're doing this on a fifth axis or horizontal is going to sort of determine initially how you're going to set your planes up. It's pretty close to the same. Just on the horizontal, whichever faces your top face, you can't machine that one, right? So on the horizontal, if this circular feature face was the top facing up, then we'd only be able to get to the sides for machining those shapes. Whereas in the fifth axis, we can do this as well as all the side faces. Okay, so we're just gonna do this as fifth axis basic setup. So first thing we need is something that's going to be our top plane. So when we're looking down through the spindle, what's going to be facing up when everything is at 0 rotation. So the way we've done it so far is we've had this circular one first because that's where we put the engraving for Laney College. So I'll go ahead and use that one. Go to my planes, and I'm going to say from solid face. Alright, doesn't really matter which way my X is facing as long as Z is pointing up. Okay, so I'm going to call this plane is going to be my top. Basically, both rotations, A and B, which is designation for rotation on the fifth axis. So it's going to be A0, B0. So I'll say this is top, A0, B0. Yeah. Alright, so green check there. And I'm going to go ahead and make that one have the WCS, the C, and the T. So everything is current on the top plane. If I do a right click top, alright, so this is looking down the spindle on the vertical machine. Okay, so that's our A0, B0. Alright, so for the first op, we just go ahead and create toolpaths as if we were on a vertical mill. We can machine, we can face it We can profile around the outside, so I'll just go ahead and throw those toolpaths down real quick. Face, choose a rectangle, and I'm not going to get crazy. I'm just going to go ahead and throw a 1/2 inch end mill at it, because that's what I'm going to go around the profile with, and just keep it simple. So 1/2 inch end mill for aluminum. 0. Alright. Okay, so just a quick little facing toolpath. Then I'll go ahead and just contour the outside perimeter. Same tool. All this stuff is just kind of my default setup. So my linking is going to be -1.5 inches. Alright, so we faced it, did the outside profile. So what we can do now is we can go ahead and just cut this shape. So contour. That. For this, we're going to use a 1/4 inch end mill. That's the width of the cut there. And just do that. Cut parameter is going to be computer, just because there's not going to be any lead in, lead out. Alright. Depth cuts. Alright, like I said, no lead in, lead out. Don't need multi passes. Just going to do a couple of depth cuts. I think it goes 1/2 inch deep. Let's see. .4875. Alright, so there's that. Alright, so now we got that. So I'll just throw a quick little stock setup on there real quick just to give us something to look at. Alright, so highlight those. Face, profile, and cut the circle. Alright. Go ahead and deburr those edges too. I did that on the real part, but you guys already know how to do that. Alright, so now we need to rotate. This is where it helps to know sort of which kind of unit you're using. For our 5th axis, so the body of it is sort of underneath the part. Okay, so you can think about it as this is the orientation of the part, and down here underneath the part, what's holding the part is the 5th axis unit, it's the part that rotates. And you think it's going to rotate to either show you this face or show you that face, right, through the spindle. Thing is, if it rotates this way, then the body of that 5th axis unit is going to be facing you, the operator. So you don't really want that because you want to be able to see the part. So you're going to rotate it this way so that the body will be out here towards the back wall of the machine, and your visibility is unobstructed by the unit. So this will be our second face. Alright, so what we need because again, we need another coordinate system for this face. So, planes from solid face, like that. Now, we need the X to point the same way that the X on the top is facing. So, over there to the right, green check. And so this is going to be our A90. All right, so the A-axis rotating about X is going to rotate 90 degrees to have this face pointing up towards the spindle. So green check there. All right, now the way that we create rotation here is WCS needs to stay with our top plane. C and the T go to our rotated plane, like that. So when Mastercam sees that in the toolpath, that's how it knows to create that A90 code and cause the unit to rotate. So let's go ahead and create the toolpath real quick. You can make another toolpath group if you want to. It might be a good idea just to kind of organize so we know what's where. Alright, so let's see. So contour, same thing. Actually, loop. Like that. Okay. All that's going to be the same. Now, if we come down here and look at our planes, so we can see top A0, B0 is our work coordinate system. A90 is our tool plane and our construction plane. Okay, so green check. Oops. Got to put the depth in there. Alright, so minus 0.4875. That was. Alright. Generate. Okay. Save it real quick. Now we can go ahead and re-verify. Alright, so now we got two faces. And so we're going to continue like that with the other faces, but now we went from this face to this face by rotating about the x-axis. Alright, so now we're in this orientation, and now to get to the rest of them, so now we're going to start rotating this way around the part to get to the alternate faces. Okay, that's going to be B-axis rotation, because that's actually rotating about Z. Okay, so we rotate it this way, and then again, so we want to keep our Y and our X going the same way, to the right. X is going to be going to the right. Y is going to be going towards this, what is that? Wherever that shape is, hexagon. Okay? So Y will be pointing toward the hexagon face. And of course Z will be pointing up away from the part. So another new plane. Solid face. Okay, again, pointing our X to the right, Y is going up. And this one is going to be A90. and B90. Because now we've rotated 90 degrees in A and B to get to this face. So green check. All right. So we're going to leave the WCS on the top A0, B0 plane. So we're going to leave the WCS there. And now our C and T come down to the A90, B90. Just like that. Okay. Again, if you want, you can do a new toolpath group. And contour again. Same thing. The same. Alright, again, look at our planes. So our work coordinate system stays at the top A0, B0, and the tool plane and construction plane go to the A90, B90. Alright, so green check. Alright, I'm going to go ahead and do the same thing again over here on this face. Here, again, X to the right, check. So this is going to be A90 and B180. C and T. Okay, again, planes. Okay. And the last one more. A90, B270. C and T. Planes. Once again. Alright, there we go. And let's go ahead and verify it real quick. Alright, so there we go. So, some things to keep in mind doing this method. Now, when we did the real one, after we would cut the shape, then we would come back with the chamfer and deburr the edges. So that had kind of a safety effect in that there was a tool change at every rotation. So we didn't really have to worry about clearance. Now, if we left it the way it is right now, we only have the one tool, the 1/4" end mill, doing stuff on each rotation. So we would need to put in clearance, right? So we would go in here into our linking parameters, and we'd put some clearance in there, right? We'd go up a couple of inches, something like that, right? And so we'd do that on each one. Just activate clearance. Maybe on this one too. All right, regen all. All right, and then we'd have clearance. All right, now this is kind of the simplest way to get this positioning. Simple, I say, for the programmer. This becomes a pain for the setup person or the operator because, as you notice, we put a plane on each face. And so when we use a plane in Mastercam, what does that mean? That means we got to set that up at the machine, right? So that means we have 5 different offsets that we have to set at the machine. You know, not exactly difficult on this part because it's pretty easy to find the center of these faces. But as parts get more complex and the outside shape changes, using one centralized plane location or center of rotation becomes more and more attractive. So that's how we did it on ours, and I'll show you that right now. This thing has to come up here. So here's this. All right, so this has got the whole ball of wax. It's got the 5th axis unit and everything in there, right? So you can see that my plane is down here. See, my A0 origin is down there sort of inside the part. So how is that? Well, the documentation of the unit gives you the location of the center of rotation. So it's, of course, in X and Y, it's just going to be the center of the platter that spins here. But for Z, they give you the number, and I can show you. It's a round number, you can tell. So if I pick on the bottom here, so Z is minus 7.5, right? So center of rotation on this unit is 7.5 inches from the floor, and then the center of the rotating platter. So then when we look at the planes, all the planes, they're in their proper orientation. All right, so here's the B180. So they're in the proper rotation. Okay. But they're all located at the same origin spot. So this is much easier for setup. It only requires one offset. But you do have to watch out. Clearances get a little bit more tricky. So it's all kind of based on how you want to operate. All right. So I hope you got a little bit out of that. And see you on the next one.